In the previous chapter, we learned a lot about all three sides of a triangle and all the angles related to a triangle. In this segment, we're going to begin, we're going to continue to study triangle, but this time we're going to focus on midsegment. First of all, make sure that you copy down these definitions and understand the meaning of it. And now let's focus on the first theorem, Midsegment Theorem. This theorem basically states that if you find the midpoint of two sides, so for example, D is the midpoint of AB and E is the midpoint of CB, and if you connect the two midpoints, you're going to have what we call a midsegment, DE, right here. And there are some characteristics about DE that's really helpful. First of all, this midsegment DE is half as long in length as the line opposing to it. So in our example is AC, and that's stated right here. So DE is half of AC. And secondly, DE is also parallel to AC. So as soon as we mention the word midsegment, it gives you two important pieces of information. It parallels to the line that it's the opposing line, and it's half as long as that line. So let's see how we can use this. A large triangular window is segmented as shown. In the diagram, DF and EF are midsegments of triangle ABC. So DF is right here, and EF is right here. And we need to find DF and AB. So notice that AB should be twice as long as the midsegment FE. So this is a pair. And DF, I don't know its length, but that should be half as long as the blue line BC. Okay, so that's just based on what I know about midsegment theorem and what's given in the question. So let's see if we can put it in a more intelligent manner. Here it says DF and DF should be twice as long. I'm sorry, DF should be half as long. So let me erase that. DF should be half as long as BC. Therefore, it should be half times 90 because BC is 90 degrees. So 90 inches. So I should have 45 inches as my answer here, right? And then now let's look at the red part. It says AB should be, in this case, twice as long as FE. So what's given is FE is 45 inches, and therefore AB is 45. I'm sorry, AB is 90 inches. I cannot do arithmetics. 90 inches. Okay. So that's that, and there's a quick checkpoint for you. This should be fairly easy to answer. If you have trouble, please make sure you approach me. Now let's look at this example. In the diagram at the right, QS equals SP. QS is right here, and that equals SP. And PT is here. That equals TR. So what that tells me something about S and T, right? They must be midpoints of both, and therefore the line ST, or the segment ST, is the midsegment. So now I have to show that QR and ST are parallel. QR is, where's QR? So it's this line. Oops, sorry. QR and ST are parallel. So it seems like it's a lot of information. let's see how we can proceed. As I mentioned earlier, because QS equals SP and PT and is equal to TR, we draw the conclusion that S is the midpoint. Oh, it's really terrible to write with this stylus. And S is the midpoint of QP, and T is the midpoint of PR by definition. Then, therefore, ST is a mid-segment of the triangle PQR, right? And by mid-segment theorem, which states that if I have a mid-segment, then that mid-segment is parallel to the to the sides, to the side that it's to the side QR. Mid-segment theorem. Make sure your handwriting is much better than mine. Okay, so that's how we use the definition of mid-segment theorem. Again, the mid-segment theorem gives us two pieces of information that's really important. It states that the segment connecting the points are called the mid-segment, and that's parallel to the third side, and it's also half as long as that third side. So in our example here is ST is parallel to QR, and it should be half as long as QR. Now we look at a slightly different concept, how to place a figure in a coordinate plane. It sounds super dry and super abstract. Basically, it's asking you to take a triangle or parallelogram or rectangular, whatever it's given, put it in a coordinate plane, XY coordinate plane. And obviously, the easiest thing to do is to line one sides on one of the axes, and that way it gives you some easy numbers to calculate with. So, so let's look at this example. Place each figure in a coordinate plane in a way that's convenient for finding side length. Like I mentioned, line up one of the sides with the x or y coordinates. Then assign coordinates to each vertex. First, we want to do a square. The solution is it's easy to find length of horizontal and vertical segments and distances from 0, 0, which is the origin, right? So place one vertex at the origin at 0, 0. You can write either one here, and one or more sides on the axis. So let's look at example A. We're asked to put a square on the coordinate plane. So in this diagram below, let S represent right here. Let me see if I can draw this carefully. So this is 1S right here. And because it's square, all four sides are measured the same length, which is S, right? So the side length equals S. So notice how I got this part lined up with the origin, and how I got one of the sides lined up with the x-axis, and that way the rest of the lines are just automatically falls into place, which makes it much easier to see that this part, the length of this part is S, and if I have to calculate the parameter or the area, it makes it much easier because I put one of the vertex on the origin. Reduces some of the calculations, basically. And same thing with example B, we're asked to put an acute triangle. So acute triangle, we all know, is like all three angles, interior angles, have to be less than 90 degrees. So you just pick one side, put it on the axis, make sure that one of the vertex um, is on the origin. And that way you need to use, in this case, you need to use three different variables, right? Because you have 0, 0 here, you have B0 here, and here it's, they use AH. You can use CD or some other numbers, some other letters, it doesn't really matter, but you can easily see what the how to read the coordinates of that vertex. Okay, here's an example. We need to use the square that we drew in example 3, and then we're asked to find the length of the diagonal as well as the midpoint. Well, let's focus on the length of the diagonal first. Notice that because it's a square, I have a right angle here, a right triangle here, and therefore I can use my Pythagorean theorem if I know the length of my two legs, CD and CB. Now, in order to know the length of my two legs, I can use the distance formula, right? So if you recall, that if I use the distance formula, it should be s minus 0 squared, and because it's a square, the other one is also s minus 0, so that will give me the distance between BC. And if I square both legs and then take a square root, I would get my I would get the length of my hypothesis, which is hypotenuse, which is BD. So that's the formula there. So therefore, I can simplify that to s squared plus s squared, and I would have 2s squared. And if I take the root of x squared, I would have s root 2 is the length of my BD. And be careful when we look at the midpoint. Here it specifically asked us to find the midpoint, meaning the coordinates of the midpoint. And so you have to use the midpoint formula. Remember, I've said it many times that midpoint, to find the midpoint coordinates, it's like taking the average. So if you take the average of the x coordinates, you take the average of the y coordinates, you will find the midpoint, the coordinates for the midpoint. So if I just simply, oops, sorry, give me the pen. So if I simply add the two coordinates together, take an average on the x-axis, and then add the two coordinates together, take another average on the y-axis, my midpoint coordinates should be s over 2, s over 2. That's my final answer. Okay? So make sure you complete these checkpoints. I know that it's a new concept, and you need to do a lot more thinking compared to the practice problems you had in the previous chapter. But if you take your time, carefully analyze your diagrams, this is really straightforward information. It's not that hard at all. Good luck, everybody.